seen is basics. Big sign right here. With computing, we got the machine control. We need posts. And then we're going to put rope. Okay. Inside, you come in here. There's going to be a table with a box. Here's the ball. And then two people come in. One is blindfolded. And you try to do this. Okay? This is a good example of machine control. I want you to write the program in computing, everybody in computing. I want you to add all the numbers from 1 to 100. Write me a program. Electrical, I want you to do how do we measure? How do you measure resistance in electricity? You know what a resistor is? Do you know how to read this? This is a code. This is a code for electronics. If you build a circuit, you need to calculate resistance. You said, I need a 33,000 ohm resistor. I need a 10,000 ohm resistor. I need a 22 ohm resistor. The code is color-coded on every resistor. You can read it. Each one will be here. You're going to explain machine sequencing. And you're going to build an example of this. Okay? Okay, give me an example. Archimedes water screw. This will be in one table. And you're going to rise water, make it go up. Okay?
It's work very slow.
Yeah, hopefully it'll be red. Red one. Can you make a spaghetti bridge? More. I want you one. Electronics. We're going to have a series circuit and parallel circuit. Parallel circuit.
You're making a project now. You're making a machine.
Well, that's a template. You're going to cut around there.
Yeah, I can do it.
This way, and then this here. Farazama. Yeah, she's doing a very nice job here with the sequencing, machine sequencing.
Strifoam loudspeaker. Actually, we made it, and also we are going to explain how does it work. Just the most complicated part is this one.
Oh, it's working. Wow.
Hey, this is a loudspeaker. It must work.
Ah, speaker.
So you're going to rope everything off?
Yeah.
Okay. Measuring them off and then making them even space. You do a good job. You could get a job in, the public sector doing this kind of thing. That's what you could do doing.
It's in my office. What happened?
Oh.
Yeah, this is
Do they
great.
work? No.
Not yet.
Not yet.
You see?
We should run a
Like
test
this.
and see if it really works. You go and do it.
Down, the magnetic is like this.
Silja atsana işin bittiyse.
Like this. Okay, so do that.
It's a group of electrical engineering
Stop. Your name once more?
application.
Shukir, you must watch this.
What?
Yes.
Where's your bridge?
It's just one paper and two plants.
Do you have a poster?
What?
Do you have a poster?
I will do it one
If
day.
you memorize this sentence, you'll remember this code. Big brown rabbits often have B, B, R, F, O, L is yellow, yield big, great big, G is green. So if you memorize this sentence, you will be able to read a resistor. On a robot, and do you know the Mars rover? Mars rover. Type this in Google.
Here is Professor Ray.
Give me a picture of a Mars rover, and give me a robot from a movie. What movie is it? The Day the World Stood Still. How many? 4? 4? 2? How many like this? X. 1, 2, just two more.
We got the basic programming flow chart all taped up there. How are we doing there, Ray?
Well, we're doing okay. We got the industrial engineers working on machine sequencing. And he's checking on I've got him finding 2 pictures of robots.
Shakir's looking for
the
robots.
computing. And your name once more. How do you say? Now Hakov. They're doing it. Go faster, please. And we got Ahim over here. Amin. He's working on the ohms, how do you read ohms scale? We got the Archimedes screw. I just sent the Russian kid out.
Badmin.
Yeah, the badminton to find out how old it is. Every poster, look here, let me check. We're making these posters. Every poster will have a question at the bottom for the other students to be asked. The non-engineer students, every line will have a question. What do you think? Is this enough power to cause an explosion? Okay, something like that, to make it more interesting. The students are doing a good job. Very good job. Dakhaja. He is from Mongolia. He's doing a terrific job.
All right, late the night.
Good night.
It's after 9 o'clock and
We're still here.
We're still here working on it. Got the signs going. Yeah, wow, we got some. Engineering Expo. It's the big day of the Engineering Expo that Ray put on with his students in his English for Special Purposes class. It'll be the first of its kind. We have computer, civil, industrial, electrical, way over there, electronics, all areas of engineering. Okay, this is the computing.
I want to be the robot. And you can add any how many level you have.
It's been good.
Very good.
No, she's gonna control my hand.
Yes.
To her commands.
You can only use these. Okay? Only do what she says.
Commands.
Only do what she says.
Go,
Okay.
stop, turn right, turn left, body up, body down, arm out, arm in, fingers up. Yeah, because you get a partner.
Figured out.
Partner. You got 3 minutes to get the balls.
No, she didn't say hand up.
Stop! Turn right. Turn right.
Stop.
Go.
Hey, let her do the commands.
I said to you, use it. But I didn't know what to do.
Not that sharp.
Hello, we got the Archimedes screw, so you can explain it?
Yes, we can explain.
Okay.
It's called Archimedes screw, and it was made in the 3rd century. In the 3rd century there was no electricity, so people tried to use this machine to transfer the water from down to up. For namely used in civil engineering, and nowadays it's used in India and some other countries where there is a lack of electricity. For example, I can demonstrate you by rotating this one. So, use red water, to see water is really water going up. Yeah.
Okay, and the water's coming out on that end.
Yes, into that.
Ray, rubbing out.
This is a handmade electroscope made by me and my partner. Here he is. And this device is called electroscope, and the wire is made up of copper, and the leaf here, down here, you can see in the bottom is made up of aluminium. It's an aluminium leaf, and this device is the best device to prove that, to show that the electrons exist, to prove it, and to do that. Firstly, we need some free electrons, and then when we get it closer to the top of the wire, we can observe that these leaves are repelling each other. Why? Because the free electrons on the top are going through the wire, down, flowing, and it's collecting here. And while it's collected here, it is repelling each other, because the electrons are negative charged particles which are circulating around the atom, and they, as we know, they hate each other. Both sides are becoming minus charged, and that's why it repels.
All he's combing his hair.
Okay.
What are you going to do with that?
You can observe that
I have no electricity.
you have no electricity.
Yeah.
When you put it very close to the top of the electroscope, this leaf, aluminum leaf, will expand because electrons are the negative charged particles are repel. They repel each other. I think this
Maybe you don't have hair. Hair.
Wait, yeah.
You're
Let me
gonna do
try my
that?
hair.
You're gonna try the hair. Give it a really good rub.
Oh,
You see?
see?
Wow. Okay, they're moving.
Yeah, I have a lot of electrons on my head.
Electrons in your hair. Wow. It just keeps.
This is series, and this is parallel.
Okay.
There are two sides. This is, it's like, let's imagine that this is hero, and this is his queen.
Okay.
And these are dinosaurs.
Okay.
And or maybe bridge. For example, we are going through this way from first. You have to kill him, and he will die. So there is way open. Second one, or third one, and then you will reach him.
Okay.
This is the same way that current going. If you don't shut it down, the current will not reach this way.
Okay.
You have to close all these ones. Here, we just need to close at least one. For example, here. This is series. If we turn one, it will not break. Here, we just turn one and it will break. Because current going like this, and it splits into three ways. If it's closed, it will go through this way and reach. If both closed, they will reach here. The current will combine here and anyway reach here. If this closed, so it depends just on one.
It's like security, right? Like if they have brakes, then they still have
Yes,
this.
because
The brakes, they still have this.
This one we will have 1,000.
Ah, into the next one. You're wearing a suit coat, don't you look
And you
like?
want this?
Hi, Brad. Yeah. And tell him what it does to electricity.
Actually, this thing. What's the unit of resistance? Okay. And you can measure it all through this curve.
I see. This is because the wires going through that. Yeah. And this is just some kind of conductor or?
No, actually, each current represents something. It's just measuring.
Okay, I see.
So if it's green, then it's 5. And if it's blue, then it's 6. 5, 6.
Is the higher the number, the more resistance?
Firstly, did you get this?
No, I mean, but is the higher number more resistance?
Yeah.
Yeah.
Sorry. Come on.
I have no idea.
Look at the colors.
Yes.
2, 4, 24.
I have to combine them. Okay. 24 times 10.
10,000.
10,000.
240,000. Right?
Did you get it?
Why do we need resistors? Kind of, yeah. We don't need resistors. No, that's okay.
Now you're strong. Hi.
Think outside of the box.
How's it going?
No, it's not. Have a great match. But till now, no one could.
Oh, really?
First time
You can't do this one?
I did. But you know, Mead is the winner. Got this ball still here.
Yeah.
The first one. What we didn't even.
Oh, this is the balancing one. Because you can move it around. Can you do it? You should be able to move it so that the bead comes out.
The same. Oh yeah. Are they all together? It's just balancing. It's a laser. It's going.
Okay, now it's level.
Makes
Okay.
patterns. Okay.
Okay.
It's something like we still use. Just to it's simple machine.
Yeah. Okay, and then it tips it. Wow, you guys did it.
Suppose this is a laser.
So, how can you use that on a practical level?
You can practically use it in a laser principle, weightlifting. Even a small screw can lift a heavy weight as much as you want. It's a simple machine. By turning we can raise or lower and control this tool.
These screws is a simple machine by turning the nut, raise and lower the tube and hold low. Okay. Basic machine. How about your other basic machine?
These are the they are doing the.
You can take this block.
No idea. I have to move what?
You can move this.
How many steps? How many steps do you need to take it out?
I did it.
Well, I'll look really stupid, right?
No.
Okay.
Can I just move things one by one?
Yeah. Okay, you can do the yellow one then.
Yeah. If I move this.
I didn't do anything, did it?
And then, if I put this back in, what's it going to do? Oh, be careful. Oh.
But did you count your steps? You can count.
I think 5.
It was 7.
And then this comes out. Yay.
7. Look at this man.
7?
The answer is the 7.
7 move.
It's going down. Here. I can put a stone here. Not correct. Why?
Because it's corrugated.
Yes, of course.
And like if you see potato chips, the chips are also corrugated, so there's a
Why? Why they made it like that? Why?
So it's strong.
Yes, for
when you
not
put it
being
in-
crashed. Yes.
When you put it
But
in-
answer the question. What was the first bridge in the world?
What's the question
What
again?
was the first bridge in the world?
It was a stick.
Stick?
Ants make sometimes a bridge out of their own bodies. I was thinking like a tree across the water or something.
Yes. Yeah, she know the answer.
I looked at it yesterday.
It's a tree between a river. Yeah. Exactly.
So it happened by mistake, and people thought, okay, let's walk.
Yes, and then after, if people want to go to the other side, he just throw a tree, it go down, and he look away. So, just a minute, I'm explaining. So, this bridge is the oldest one of the modern bridges now. So, he didn't use a lot because he takes a lot of metal. So, this one is a suspension bridge. What a plus of this bridge. This bridge can be usable when it's very windy there, because it will not be very crashed. And he is very slim. So the second thing that it's good because he can be very big and it will not be too as much so resources than the others.
The arrows are showing. Is that what the arrows are showing? The strength coming from somewhere?
What do you mean?
Because you said the wind is like
Yes, because these people, you see these things. I forgot the name. It's metal.
He throws anything on his cardboard that he wants, and then the civil engineer has to make it. Like the one in Beijing, China. You know the Olympic Stadium?
Yeah.
It's a bird nest, and there is no symmetry in the whole stadium. Because it's supposed to be like a bird's nest, and the bird's nest is not a symmetry. So the poles are just going somewhere around in a frenzy. And the civil engineers have to make the exact bend the metal in that form and then stick it. So they have to know everything. So actually, the civil engineers modify everything, and they have to know a little bit of design also.
But can they go back to the architect and say like, okay, look, this is too crazy, this is not gonna work, no way.
Actually, the architect, he contacts directly to the owner, and if the owner wants it that way, then
The engineer needs to figure it out. He needs to work magic.
Maybe you misspelled.
W for engineering. And we have all these words: compression, tension, load, coil, induction, induce. Is that lead or lead? Lead?
Leads.
Resistance,
yeah.
ohms, upper lowercase, combine harvester, keel, tensile strength, register,
Okay.
shift register,
They get the idea.
flow chart, logical analog,
And on the end,
relay
is
circuit.
corrosion spelled correctly? Corrosion?
No, it's not.
Friction?
Material failure.
Material.
I don't think that's spelled correctly.
See, for example, let me tell you this. If I just make this one, if I push it to somewhere, let us add some molecules here. So it just, collide with the molecules with this area. But if I make it louder, so for example, if I just this one, it collides all of our molecules here. So the pressure in molecules will be more and more. So that's why it's also according to white objects that we have got. Yes.
Man, you guys are awesome.
Did you get it?
You're hired. You're hired.
That was amazing.
That was great.
Students work. Never Thank you. I'm happy. It came out nice. Everybody learned something. And the students were very good. Very good. I'm happy. Thank you for your help.
Okay. Everybody smile and say engineering.
Engineering Expo. Almost over.
Bye.
I think it's a success.
It's a success.
And the students work very hard.
You guys did a good job.
With the teacher's help.
All right.
Oh, it was such a great work, and I congratulate you too for your great efforts. Yeah.
Think of the expo.
It's, everybody's happy, so thank you again for your hard work.
Okay, thank you.
It's a great success. I think Ray did a very good job, and the students are very motivated. They are very motivated to be here, and they are enjoying the lessons with Ray. Well done.
Oh, thank you.
Oh, it was awesome. I mean, even though the theme was basics and it was really simple things, all the students were like, oh, this is too simple. But honestly, I was impressed and surprised, and I learned a lot from all of them. So it was a great opportunity to learn something from the students that we teach every day, because obviously they're intelligent and have so much to share with us. So I'm excited to see more and to see where these kids go. It was incredible.
Thank you.
Yeah.